Dear cadets, I am Sheikh Wajid Ali and I would like to extend my warmest wishes to you all in today's class. I hope you all are fine at your sweet home. As you all know that due to corona pandemic, the whole country has locked down itself and so it is struggling with the lack of education everywhere. For this very reason now I am here to take your online class on mathematics and you must be attentive to use the advantage of it. Dear cats, I would like to remind you of the critical situation prevailing around the whole world, COVID-19. You must cautious about this dangerous virus. You maintain social distance, and here is some steps for you. You just follow this, okay? Boys, can you guess from this picture what we are going to learn today? Yes, our today's topic is statics, learning outcome. After the lesson, you will be able to apply parallelogram law, explain rectangular solution, and also find the resultant of two or more forces acting at a point. This is the main theme. Okay, now here is the magnitude and direction of the resultant. In previous class, we discussed about parallelogram law and today I just remind again you that here is the two forces P and Q. They are including angle alpha, and here the resultant are along the diagonal of parallelogram and it makes angle theta with force P. Here is the resultant R equal to square root of P square plus Q square plus 2PQ cos alpha, and direction of resultant theta equal to tan inverse Q sin alpha divided by P plus Q cos alpha, and direction of resultant must be along with force P theta degree. Okay, and here is rectangular resolution. Rectangular resolution means one force and its resolved part along the axis, x-axis and y-axis. Here along x-axis, R, resolved part of R is R cos theta. R and cos and including angle between R and x-axis. And OB equal to R sine theta. Here along y-axis is r sine theta. Okay. Now to find the resultant of any number of coplanar forces acting at a point. Here we see that any number of forces. In parallelogram law, we can use only two forces acting at a point. And for this formula, we use for any number of coplanar forces acting at a point. We see that OX and OY is two axes, and P1, P2, and P3 three forces, and they makes angle alpha 1, alpha 2, and alpha 3 along x-axis. Boys clearly noted that all angle must be with x-axis. Okay, and here is the resultant R. It makes angle theta with x-axis. So boys, now our theorem is result parts of the forces and their resultant along and perpendicular to OX and OY respectively, that R cos theta, that is result part of resultant R cos theta, and result part of resultant equal to the result part of all forces, sum of all forces. P1 cos alpha 1 is result part of this P1 forces, P2 cos alpha 2 is result part of P2 forces, and P3 cos alpha 3 is result part of P3 forces. So result part of resultant equal to sum of all forces. Result part of sum of all forces. So this is result part of x-axis, along x-axis. Here it is along y-axis. So y-axis are sine theta, result part of resultant, and here it is the result part of all forces. Here P1 sine alpha 1 is result part of P1 along OY. P2 sine alpha 2 result part of resultant P2. Result part of force P2. And P3 is result part of force P3. So boys, so here we see that result part of resultant equal to the result part of all forces. So we can use only these two formula. One is parallelogram law and another is this coplanar forces result parts formula. And we use these two formula and solve all the problems. Now we are going to solve problems. Okay. Now problem, the greatest and the least resultant of two forces acting at a point are F and G respectively. If the angle between the lines of action of the forces, then show that their resultant is F square cos square alpha by 2 plus Z square sin square alpha by 2 its square root. So I again repeat this question. The greatest and least resultant. Boys, I know that you all know that the greatest of two forces, that is P plus F plus G. Here F and G is two force. So F plus G is the greatest resultant and least resultant is F minus Z. So here two forces, we let two forces P and Q, and its maximum value of the resultant is F equal to P plus Q, and minimum values resultant P minus Q. Okay, and now again summing these two equations, we get 2P equal to F plus Z and P equal to F plus Z divided by 2. Again subtract equation 2 from 1, we get 2Q equal to F minus Z equal to Q equal to F minus Z divided by 2. And let alpha be an angle of the forces and the resultant is R. From the parallelogram of law of forces, we say that R square equal to P square plus Q square plus 2PQ cos alpha. And we just put the value of P and Q here. Then we got P plus F plus G divided by 2 whole square plus F minus Z divided by 2 whole square plus 2 into F plus Z divided by 2 into F minus Z divided by 2 cos alpha. It is the value of P and it is the value of Q. And after simplifying that, we get that 2 F square by 4 plus Z square by 4, 1 by 2 F square minus Z square. That is A square plus B square, A plus B whole square plus A minus B whole square is 2 into A square plus B square. And now, that is we get from this 1 by 2 F square plus Z square and 1 by 2 F square minus Z square cos alpha. That is 1 by 2 F square, and here it is 1 by 2 F square cos alpha, and we put this together. 1 by 2 F square 1 plus cos alpha, and 1 by 2 Z square and minus 1 by 2 Z square, we take common, minus common 1 by 2 Z square, then 1 minus cos alpha, and 1 plus cos alpha equal to 2 cos square alpha by 2, and 1 minus cos alpha equal to 2 sin square alpha by 2. Here we see that 1 by 2 F square into 2 cos square alpha by 2 plus 1 by 2 Z square into 2 sin square alpha by 2. And that is 2 to cancel, so F square cos square alpha by 2 plus G square sin square alpha by 2. So the value of the resultant R equal to square root of F square G square cos square alpha by 2 plus G square sin square alpha by 2. So boys, this question, this problem, we see that the maximum resultant is summation of two forces, and the minimum resultant is the subtraction of two forces or difference of two forces. And now we're going to the problem next. Now problem 2. Two forces P and 2P acting at a point A have a resultant 3P if any conversal cuts the line of action of the forces at the point B, C, D respectively, then prove that 3 by AD equal to 1 by AB plus 2 by BC. A kind of solution we see from the picture. Here OX is x-axis and here OB, OD is and OD are the three lines, and transversal is that intersects B, D and C point. So now we have to show that 3 by AD equal to 1 by AB plus 2 by AC. So draw a perpendicular OX from CB from the point O. We know that an algebraic sum of result parts of the two forces acting in any direction is equal to result part of their resultant in the same direction. That is, hence taking result part along OX, result part P cos BX equals 2P cos CX equal to 3P cos DX. Its resultant result part and it the forces result part. So we omit P, then we get here P into AX by AB. Here this is the value of cos BX and 2P plus 2P AX by AC. It's the result part of the value of cos CX equal to 3P AX by AD. It's the value of cos DX. Okay, we then find out P and X, then we get 1 by AB plus 2 by AC equal to 3 by AD. So that's our desired root. 3 by AD equal to 1 by AB plus 2 by AC. From this question, we see that there is two forces and there are one resultant and three line cuts at a transversal. Then we have to show this. Okay. Now, another problem. The resultant of two forces represented by the chords AB and AC of a circle passes through the center of the circle. Prove that two forces are equal or mutually perpendicular. So, from this picture, we see that here two forces and its forces are equal. We have to forces passes through the center. So two forces passes through the center and we have to prove that two forces are equal or mutually perpendicular. Let the center of the circle be O and OD is perpendicular to AC and angle AOC equal to TB. We know that the angle at the center is twice the angle at the circumference. So, therefore, angle AOD equal to angle COD equal to B. Okay, it's equal. So, angle OAC equal to 90 minus B. OAC equal to 90 minus B. Now, similarly, angle OAB equal to 90 minus C and resultant of AB and AC acts along AO is from the sine rule. We get that AB by sine OAC equal to AC by sine OAB. That is from, we know that like we have sine rule of triangle, we have the force divided by the angle between two other two forces sine and P Q divided by sine angle between R and P equal to R divided by sine angle between P and Q. That is the ratio of force and divided by sine of their other two angles. Okay. So here from this picture AB divided by sine 90 minus B equal to AC divided by sine 90 minus C, and that is AB by cos B equal to AC by cos C. So from the sine rule again we can see that AB by sine C equal to AC by sine B, and we divide 1 and 2, then we get AB and AB out, that is sine C by cos B equal to sine B by cos C, and we can write that 2 sine B cos B equal to 2 sine C cos C, and again we can write that this is sine 2B and this is sine 2C, so 2B equal to 2C, that is B equal to C, so AB equal to AC. Okay boys, and now our next problem, similarly we can say again sine 2B equal to sine 2C, and sine 180 degree minus 2C equal to 2B equal to 180 minus 2C, that is B plus C equal to 90 degree, that is A. So AB is perpendicular to the forces perpendicular. So if that is the four forces are equal and it's AB perpendicular to AC. Now next problem is two forces P and Q acting at a point have a resultant R. If Q have doubled and R is doubled, again Q is reversed by direction, then also R is doubled, so that P is to Q is to R equal to root 2 is to 3 is to 2. So here the picture, and now let the angle between the forces P and Q equal to alpha. P and Q equal to alpha, first case. And then the parallelogram law of forces is R square equal to P square plus Q square plus 2PQ cos alpha. And if Q be doubled, so Q is double and R is double. So if Q is double, again second condition is that P and 2Q. So P and Q, 2Q, and acting along the same line, the resultant is 2R. So here 4R, that is 2R square, that is 4R square equal to P square plus 4Q, that is Q is replaced by 2Q, that is 4Q square plus 4PQ cos alpha. And third condition is Q is reversed in the direction. So then the resultant is 2R. From this case, the angle between P and Q is pi minus alpha, that is 4R square equal to P square plus Q square plus 2PQ cos pi minus alpha. So here, that is 4R square equal to P square plus Q square minus 2PQ cos alpha. The value of cos pi minus alpha is minus cos alpha. So again, adding 1 and 3, we get 5R square plus 2P square plus 2Q square. That is 2P square plus 2Q square minus 5R square equal to 0. So again, adding equation 2 plus 2 into equation 3, we get 12R square equal to 3P square plus 6Q square. Again, simplifying this, we can write P square plus 2Q square minus 4R square equal to 0. That is equation 5. And by cross multiplication process, equation 4 and 5, we get P square by minus 8 plus 10 equal to Q square by minus 5 plus 8 equal to R square by 4 minus 2. That is P square divided by 2 equal to Q square divided by 3 equal to R square divided by 2. So we can write that P is to Q is to R equal to root 2 is to root 3 is to root 2. Okay, what's the next problem? The next problem is the resultant of two forces acts along a line perpendicular to one forces and is half the other. Show that they are at an angle 150 degree. So here we see from the picture, that is two forces P and Q. Their resultant is R is perpendicular to P, and we have to show that the act angle, that is alpha equal to 150 degree. So let the resultant of two forces P and Q acting at an angle alpha be R, which is perpendicular to P, then R equal to Q by 2. So now taking the result parts of the forces along the direction of P direction, then result part H, P cos 0, that is angle P, angle P or angle of P forces with P is 0, that is P cos 0 plus Q cos alpha plus r cos 90 degree. So from this we see that p square plus q cos alpha equal to 0, that is p equal to minus q cos alpha. And from the parallelogram law we see that r square equal to p square plus q square plus 2pq cos alpha, that is here r equal to q by 2, that is q square by 4 equal to q square cos square alpha. From this we can write p equal to minus q cos alpha. So from q square minus 2q square cos square alpha, and simplifying we get cos square alpha equal to 3 by 4, that is cos alpha equal to plus minus root 3 by 2, and taking plus sign we can write cos alpha equal to root 3 by 2 equal to cos 30 degree, and alpha equal to 30 degrees is not acceptable because the resultant angle is 90 degrees. So alpha must be greater than 90 degree. And taking minus sign, you can write cos alpha equal to minus root 3 by 2. That is minus cos 30, that is cos alpha equal to cos 180 degree minus 30 equal to cos 150 degree, that is therefore alpha equal to 150 degree. Okay, so boys, there we solve from this question the problem, that is our included angle must be the greater than the resultant. Okay, so now another problem, and when the two equal forces are inclined at an angle to alpha, their resultant is twice as when they are inclined at an angle to beta. Prove that cos alpha equal to 2 cos beta. It's the easiest problem. So let the resultant of two equal forces P and P acting at an angle to alpha be R, and acting at an angle to beta be R1. So R equal to 2R1. So we resultant is twice from previous one. So R equal to 2R1, that is R square equal to 4R1 square. So from R square we can say that R square equal to P square plus P square plus 2P square cos 2 alpha. At angle 2 alpha. And from R1 square we can say that R equal to P square plus P square plus 2P square cos 2 beta. Okay. So here after simplifying we can write 2P square plus 2P square equal to 2P square equal to 2P square cos 2 alpha. And here 4 into 2, that is 8P square plus 8P square cos 2 beta. And again, we can write that 2P square 1 plus cos 2 alpha, 8P square 1 plus cos 2 beta. And here 2P square out, then we can write 1 plus cos 2 alpha equal to 2 cos square alpha, and here 4 into 1 plus cos 2 beta equal to 2 cos square beta, and therefore cos alpha equal to 2 cos beta. Okay, that's all for our today's discussion. I hope you all understand today's lecture, and you have to solve this type of problems. Okay, if you exercise your 8A section, then it will be easy to solve all of your problems. And we're going to, in next class, we're going to 8B section. Okay, that's very easy. So that here is your homework. Number one, the resultant of two forces act along a line perpendicular to one force and is half the other, show that they act an angle 150 degree. And number two, the resultant of two forces acting at a point at an angle 150 degree makes right angle with the smaller one. The greater component is 100 Newton. Find the smaller component and their resultant. So now boys, I again remind you the critical situation. Please keep safe from everyone. You just maintain the social decorum for COVID-19, and some, all know the steps. You should remain cautious about this, and I hope you all are doing this, and thank you for viewing this class. I hope all of you are fine. And now I conclude here to this lecture. Allah Hafiz.